So today we're going to be considering why the first derivative of cosine x with respect to x is equal to minus sine x. So in order to prove this result, we simply can do this by recalling our definition of a derivative from first principles, which is defined as the limit as h tends towards 0 of our function at x plus h minus our function of x divided by h. So recalling that our function is cos of x, we can therefore rewrite this as the limit as h tends towards 0 of cosine x plus h minus cosine x divided by h. And now this cosine x plus h term can look rather intimidating, but we recall that using the double angle theorem, cos of x plus h is so defined as cos x cos h minus sine x sine h. And now by doing that, we can replace this expression in here, and we end up with the limit as h tends towards 0 of cos x cos h minus sine x sine h minus cosine x from here divided by h. And now, in order to more easily evaluate the limits as h goes towards 0, we can make the final line here by grouping our sine and cosine terms together, so we can split this into two terms. So we'll have our first term as the limit of h as h goes towards 0 of minus sine x sine h divided by h, which is just this term here, plus the limit as h tends towards 0 of our cosine terms. So we have cos x cos h minus cos x divided by h. Pause the video at this point if you would like to attempt to finish this derivation yourself. If not, keep watching. So now, following on from that previous line, we can now pull out our terms that are just in x, i.e. leave our sine h's and cos h's in the limit. So we can say that the previous line can be written as minus sine x for the limit that h tends towards 0 of sine h divided by h minus the cosine of x multiplied by the limit as h tends towards 0 of 1 minus the cosine of h divided by h. And now, simply here, through L'Hospital's rule, we can derive this limit as, if you differentiate the top using L'Hospital's rule, we'd get cos h divided by the derivative of the bottom, so the derivative of h dh is 1. At 0, this would give us cos 0 over 1, which in other words, 1 over 1. So this thing here is equal to 1. And performing the same trick here, differentiating the numerator, well, minus cos dh goes to sine h over h dh, which is 1. And now we say sine, this is evaluated as limits h goes towards 0 over 1. Sine 0 is 0, divided by 1 is 0. So this whole line here, what we'll see is this term will disappear, leaving simply minus sine x times 1. So therefore, we've successfully shown that the first derivative of cosine x is indeed equal to minus sine x. Thank you for watching, and I'll see you in the next video.